task assignment and scheduling. So what is task? A task is the smallest schedulable unit managed by the OS. The OS decided when which task can run the CPU. The purpose of the real-time computing is to execute a task by the appropriate deadline. So we look at the technique for allocating and scheduling the task on the process to ensure that deadlines are met or not. So the task assignment scheduling. So task has a resource requirement. Okay, all the tasks require some execution time on the processor. Also, tasks may require a certain amount of the memory or access to the bus. The resource must be exclusively held by the task. So in other cases, I can say the resources are non-exclusive. The same physical resources may be exclusive or the non-exclusive depending on the operation to be performed. So the task may be in precedential constraints. What is this precedential constraints? Here, if the task Ti output is needed as input by task Tj. So let us consider the precedency graph here. The precedential constraints here let us consider for the T1 there is no constraint, but the T2 you can see it has to wait for the T1 output, and similarly 3 is wait for the T1 output, and the T5 has to wait for T2 and T3, and similarly with T4 it has to wait for the T1. Okay, so similarly T6 you can see here T6 is wait for 1, 3 and 4. T7 is wait for 1, 3, 4, 6. So obviously T8 wait for 1, 3, 4, 6 and 7. This is a precedence graph. Okay. So before saying that task assignment scheduling, we must know the parameters. So what is a release time? The time at which all the data that are required to begin executing the task available. The releasing time of the task is the time at which all the data that are required to begin executing the task are available. So what is deadline? The deadline is the time by which the task must complete its execution. It may be hard or software depending on the nature of the corresponding task. The relative deadline. What is the relative deadline? It is how to calculate the relative deadline. Absolute deadline minus release time. So Ti is, when you consider Ti is a task related deadline, deadline is Di and release time is tau. The absolute deadline is tau plus Di. So what are the types of tasks? The types of tasks are periodic task, sporadic task and aperiodic task. Okay, periodic task. A periodic task Ti is a periodic if it is released periodically. Say every pi seconds. So pi is called the period of task Ti. So the periodical constraint requires the task to run exactly once every period. It does not require that the task be run exactly one period apart. The period of the task is also its a deadline. So that sporadic task, if the task is sporadic if it is not periodic, but maybe they invoke at irregular intervals. The sporadic tasks are characterized by an upper bound on the rate at which they may be invoked. The successive invocations of the sporadic task Ti be the separated in time by at least a T of 5 seconds. Sporadic tasks are sometimes also called aperiodic. So it can occur any time, but minimum time between the arrivals. So aperiodic task can occur any time, no arrival pattern given. That is, aperiodic task is to be those tasks which are not periodic and which also have a no upper bound on other invocation rate. So next, task assignment scheduling. Here the task assignment scheduling is said to be feasible if all the tasks start after the release times and are complete before the deadlines. The schedules can be formally defined as a function, that is a set of processor into time. That is called set of tasks. Okay. So here the schedule may be a pre-computed, that is offline scheduling, dynamically or online scheduling. What is offline scheduling? Offline scheduling involves scheduling in advance of the operation with a specification of when the periodic task will be run and the slots for the sporadic or aperiodic tasks in the event that are involved. Online scheduling, tasks are scheduled as they arrive in the system. Online scheduling algorithm must be the faster one. So, task scheduling algorithm, various algorithms are there. Static periodic algorithm, task period does not change within the mode. So, example is for rate monitoring scheduling. Dynamic periodic algorithm, priority can change with the time. Example, earliest deadline first. The preemptive scheduling, the task can be interrupted by other tasks called the preemptive scheduling. The non-preemptive scheduling, once a task is begun, it must be run to complete or get locked by the resources. So, we will see the example for this rate monitored scheduling, that is introduced by the Liu and Leila. Static scheduling policy because it is assigned fixed priority to the processes. So, theory underlying the RMS is known as rate monitoring analysis. The theory as summarized below. All the processes run periodically on a single CPU. Context switch time is ignored. There are no data differences between the process. The execution time of the process is constant. All the deadlines are the end of their periods. The highest priority ready process is always selected for the executions. Okay. So, now we will see that how we can calculate the scheduling using this rate monitoring algorithm. The algorithm to schedule the periodic task, it is based on the priorities. We are giving the highest priority based on the period. Okay. So, we can see the example here. Process P1 burst time is 2, P2 is 1, P3 is 5, P4 is 2. So, the period for this P1 is 10, P2 is 5, P3 is 30 and P4 is 15. So, the highest priority for is P2 5, P1 is 10, then the next priority is for P4, then the last priority for P3. So, we have to calculate is it whether it is possible to schedule the processes so that all them meet their deadlines. Okay. So, the formula is n into 2 to the power 1 by n minus 1. Here the n is number of processors. Here the n is number of processors 4. So, 4 processor 4 into 2 to the power 1 by 4 minus 1, that is equal to 0.7568. Okay. Now, we have to calculate utilization. Utilization, how to calculate the utilization? Ui is equal to Pi by Pi. Okay. So, you hear the Ui is equal to the burst time 2 divided by period time 0.2. Okay. So, U2 is equal to 1 by 5. Okay. 0.2. So, U3 is equal to 5 divided by 30, 0.10. U4 is equal to 2 by 15. So, 0.13. When you add all these utilizations, you will get 0.7. So, 0.7 is less than 0.7568. So, it will never miss that deadline if RM is applied. Okay, first we have to see the feasibilities. So, now we have to see this first. So, I have to calculate the LCM. So, when you take the LCM based on the period, you will get the 30. Okay, you will get the 30. So, here the total period is 30 based on the LCM. Now, we have to take this first priority is P2. We have to start with the P2. The burst time is 1, right? Within the period of 5, it has to it will be the burst time is 1. So, within the period of 5, P2 will burst 1 time, right? The next priority is P1. Within the period of 10, it has burst twice. So, within the period of 10, P1 should burst twice. So, 1 and 2. Okay, 1 and 2. And the next one is P4. Within the period of 15, it bursts twice. So, within the period of 15, it has burst twice. So, P4, so you can see P4, 3 and 4, 3 into 5. Okay, over. Then last is P3. Within the period of 30, it has burst to 30 times. So, P3 is, you can see here P3 from 6 to 10, right. So, next is we have to give the P2 2 is the highest priority. So after 5 you have to give the P2. Okay, P2 is next first time is 1 time. The next priority is next priority P1. P1 within the 10 we have completed twice, so we need not worry about that. The next P4 15. So within this 15 we have to complete P4 twice. So it is P4 is also completed here itself. So next within 30, that is we have to complete 5. So it is, we need not worry about the P3. So next one is within the 10. So P1. So once we complete so 5 to 10 we have to complete 5 to 10 we have to complete P2, right, and right, 5 to 10 we have to complete P2, and we have completed P3 also. So now we have to go for 10 to 20 we have to complete P1. So P1 we have to complete twice. Okay, P1 we have to complete twice. Same time we have to complete P2 also from 10 to 11, one time burst. Okay, the next P4 we have P4 up to P4 we have completed already, so we need not worry about it. Then 30, that is P3. So we have completed only how many times? 7, 8, 9. So the remaining is we have completed here. Okay. Similarly, you have to do all these things. Thank you.